Okay, guys, so first off, I got a little note saying that you didn't understand this part of the lab. We don't know how to do questions 10 through 13 on the back page. Okay, so here is your biggest problem. So I went through and I looked at your lab sheets and I took one home and photocopied it so I could see what was going on. So here's your problem. When you wrote your balanced chemical equation, because you have calcium chloride, CaC, or calcium carbonate, reacting with HCl, hydrochloric acid. We have 2 moles of that. You guys said it made calcium chloride, CaCO3, and carbonic acid. Problem B, did you see bubbles coming off? Absolutely, because you had carbon dioxide being released. And you also evaporated something out, and that was water. And so calcium carbonate is actually really unstable. When heated, it breaks apart to form carbon dioxide and water. You probably had a little heat as a byproduct because it's an exothermic reaction that occurred. So when you're doing this, you're like, I couldn't do any water. Well, yeah, you did have water. So in number 10, well, there's lots of reasons why you could have had it. One, you could have not evaporated everything out. Maybe didn't have enough of your limiting or excess reactant in there, so you didn't have a complete reaction. All those are possible reasons. Human error. Some of it could have splattered onto the table. So there's lots of reasons. But let's determine the amount of water produced theoretically. So you know from earlier when you solved, because I looked at your sheet, so you do have 2.2 moles of calcium carbonate. Okay, we want to convert that into water. So we have 1 mole from the balanced chemical equation of your CaCO3, 1 mole of H2O to produce 1 mole H2O, 18 grams of H2O. And so then you should have got 0.36 grams of H2O. That's how much you should have produced. Everything else would have been either your carbon dioxide produced, or it would have been your calcium carbonate. So in order to determine your percent yield from this, could you determine it? Yes, if you weighed the beaker prior to evaporation with the liquid still in it, and you took out your 5 or mils or so forth of your HCl, then yeah, you probably could have. Would it have been plausible? Not if you had some excess HCl in there still. You wouldn't have had that show up very well, so that could have been a possibility that it wouldn't have been able to be determined. But definitely, if you did not have the mass preheat, you could not determine this. If you have mass preheat, you sure can, because you could determine how much water was actually in there and how much evaporated out. Then you would have your actual over your theoretical, because we know that whatever was left in there, which you guys said was like 2 grams of your calcium carbonate. So if you had like 3 grams prior to heating up, 1 gram would have been water. But I don't know that because I didn't see anybody's calculations for that mass up there. If you didn't, you couldn't do it. Okay, so now with these, it tells us that we have HCl, which is 3, and we're using this equation right here. So we just need to set up, like it says up here, a proportion for it. So we know 3 moles is equal to 1 liter, 1,000 milliliters. We're going to use milliliters because we use milliliters to measure with. So you guys told me that using the information, determine the amount of moles that you used the reaction, set up a differential analysis, cancel it out. Okay, so you guys told me that you used 15 of the 20 moles. I looked at Tanya's paper. So I want to put 15 milliliters here. I'm going to put X up here. I'm going to simply solve for X. When I solve for X, X is equal to 0.045 moles of HCl. Well, that's really poor penmanship, sorry. Moles of HCl. So I set up a differential analysis, and I got my moles of HCl. I can turn that into grams of HCl, but it says to determine the moles. So I did. I determined the moles. So now I can also, using the information that I already have, so determine the theoretical yield of HCl. Okay, so here's what I can do. For the theoretical yield, I know that I use, for sure, because I weighed it out, 2.2 moles of calcium carbonate. So I want to convert that into moles of HCl. Okay, so 2 moles of HCl. Balanced chemical equation, molar ratio is being used right here. CaCO3. This is going to be equal to 0.04 moles of HCl. Well, from the information that I have above, I know that 3 moles of HCl is in 1,000 milliliters. So I want to determine X right here. X tells me, I'm going to put that right here. X tells me I had 13.33 repeating milliliters used. Well, according to you guys, you said you had 5 milliliters left over. So if we take 20 minus 13.3, we actually had 6.7 milliliters excess HCl. You guys said in question 4 and 5 that you had 5 milliliters excess. So this is actually showing you have a little bit of air. Could we determine percent air from this? Absolutely. You could go actual over theoretical and determine, oh, this is how close we are to actually using the proper measurements. So you can actually do that for here. So you can figure out some reasons why, but this is what you needed to do. It all stemmed from you wrote an improper chemical equation. It's okay. It happens. It's a common error. Just remember, carbonic acid is super unstable and does not stay as carbonic acid if it doesn't have to. It'll break apart to form carbon dioxide, which you saw were the bubbles coming off. It wasn't magic. They are bubbles. They are CO2. And then water, which you evaporated off. If you truly had carbonic acid in an aqueous solution, water would have come off when you heated it, but you would not have seen bubbling occur, and you would have a higher mass because you wouldn't just have calcium chloride in your container. You would have calcium chloride and you would have a concentrated powder of carbonic acid as well. All right. I hope this cleared up your questions.